the limit as x approaches 2 of the sine of pi times x minus 1 over 4 is going to be, well, we could look at this as a composition of functions, but basically we have a polynomial function, pi times x minus 1 over 4, and then we have the sine function that's composed with that. So this is going to equal the sine of the limit of pi times x minus 1 over 4 as x approaches 2. So this is the sine of pi times 2 minus 1 over 4. So this is the sine of pi over 4. What is the sine of pi over 4?
45.
Sine of 45 degrees would be, is that the square root of 2 over 2?
Yeah.
45-degree angle there. So 1 square root of 2. So 1 over the square root of 2, or the square root of 2 over 2 if you like rational denominators. So that would be what you'd get. Limit of x times the cosine of x as x approaches pi. We had a theorem up above that said the limit of a product is equal to the product of the limits. So this equals the limit of x as x approaches pi times the limit of cosine x as x approaches pi. Well, as x approaches pi, x approaches pi. So this value of this limit is pi. And the limit of cosine x as x approaches pi is the cosine of pi. What's the cosine of pi? It's over here, right?
Yeah.
So -1, 0. Cosine is -1. So negative pi is what we're looking at for this limit. Now the last one, a similar statement can be made about exponential functions and logarithmic functions. Any number in their domain, the limit can be calculated just by evaluating the function at that value it's approaching. So the limit of the square root of the natural log of x as x approaches e to the 4th power equals, well, we have a theorem about radicals. The square root of the limit of the natural log of x as x approaches e to the 4th power. So I'm simply going to evaluate the natural log at e to the 4th power. So the natural log of e to the 4th power is the power that e can be raised to get e to the 4th power as the answer, which is 4. And the square root of 4 is 2.